Alright, so when I start running the code over here, we can observe that when the heater is turned on, the current flowing through is 12.79 in that range, and the power is almost 1500. The readings here are kind of misreadings because the temperature sensor is probably missing a wire or something, but I'll fix that. But generally, yeah, when the heater is turned on, we can observe that there is a current flowing through which is measured, and through which we measure the power consumption. And this concludes that the power consumption is generally between 1500 to 1700 when the heater is running. And when it's running, it's probably 600 to 500 and decreases to zero. But this has to have a cool down time. But since the change of temperature is pretty rapid, and there's an error with the temperature sensor, it doesn't allow the power to go down to zero when the heater is fully turned off, because it only takes almost from 3 to 4 seconds for the heater to turn on again after it turns off. And so yes, this is pretty much my project, and I hope you enjoyed the video. Thank you. Hello everyone. This is my part 6 design demonstration and verification for ECE 5000 project. I'm going to start off with demonstrating my circuit component and their specification based on the I submitted last week. This is the current sensor, the specification on the screen. This is where I'm going to be measuring the current flowing through the heater, and from which I'm going to be measuring the power consumption of the heater. And the second main component is the 5-volt relay. This is where I'm going to be controlling the switch on and off of the heater based on the temperature reading of the temperature sensor. And finally, this is the temperature sensor, which is going to be connected to the Arduino to measure the temperature of the room. And over here I got my transformer tester. To extract the current flowing through the heater and make it pass through the relay and the current sensor to measure the current and to control the heater. For a better demonstration, I decided to rebuild the circuit live in this video and explain what each component does. So first of all, this is the temperature sensor, which is going to be connected to one of the analog inputs in the Arduino. You can see here there's 4 inputs: the ground, VCC, and NC in signal. We're going to be using the 3 inputs of signal, VCC, and ground for our project. And to power up the breadboard, I'm going to be connecting one of the jumping wires to the 5 volts terminal in the Arduino and plug it into the positive side row in the breadboard. Same goes to the ground. So this way all the positive terminals in the breadboard is powered by 5 volts and all the negative terminals powered by ground. So we got our current sensor, and instead of cutting the wire of the heater itself, I got this transformer tester so that I can extract the current from the heater and make it go through the current sensor and the relay without causing any damage to the heater itself. So first we plug this wire in here, and then we plug this side of the wire into the relay. And this is the first wire that goes into the relay, and then we're gonna get another wire that comes out of the relay and then goes through the current sensor. And then our relay input goes to one of the digital inputs. And then first to determine the current flowing through the relay goes through the current sensor and then goes through the transformer tester so that the circuit is complete and the heater could be turned on and off. And then our current sensor gets plugged into one of the analog inputs as well as the temperature sensor. And this way our circuit is complete. As we can see, when I'm trying to plug in the heater, I don't plug it in the wall, but I plug it into the transformer tester like this way. Without the code being turned on or being connected to the power source, we can actually test the relay and the current sensor to know whether they're working or not. When we plug the transformer into the wall like this.
Well, I don't wanna be on the mic with all these words that I think are right, and I'm a child of details, and when I pin it, it's heads, not tails. Don't you?
Yep, this way we can notice that the heater is starting. The heater turned on when we plugged the transformer tester onto the wall, which proves that the relay and the current sensor are working fine. And the next step, I'm going to go through my code and test it to see if the code is working and the specification is correct for the circuit. So I started off my code with defining multiple variables. I defined the variable switch, that's for the relay to control the heater, and the power, which is extracted from the current by getting the current from the current sensor. And then I've defined the variable temperature as float to get the temperature from the temperature sensor. And then these are for the functions for the current sensor, the temperature sensor, and the relay. And these two integers are for the temperature sensor formulas to get the actual temperature from the reading of the temperature from the temperature sensor itself. These three, and then I've defined here also the variable current. And then I started my code with the function setup, and then called the multiple functions that control the current, temperature, and the switch into the function called loop. Also here, I stepped a delay of 1 second between every reading so that it can give me time to analyze the readings and the values that coming out of the different sensors. So our first function is the current. Here I take the read of the current sensor and plug it into the variable called current, and then from this variable I multiply it by 120, which is the specification of the heater itself, and then which results into the power, and then afterwards I serial print the current, power, and the temperature. And then in here, this is my specification for the relay and controlling the heater. Since I cannot connect my code and my components to the dashboard and actually control the heater from the switch on and off from the dashboard, alternatively, I set the specification for the code so that the relay turns on when the temperature is below 25 and turns off when the temperature is over 25, so that I can get a stabilization point between 24 to 26 Celsius. And yeah, this is pretty much the alternative of controlling the heater in just an automatic procedure. And we can actually set the temperature to whatever we would like, say 24, maybe 23. It could all be controlled through this function. And then in here, this is where I convert the reading of the temperature sensor itself into an actual degree through these functions. And yes, this is my code for my system.